Hi everyone. So in this video, my plan is to talk about try to first of all draw some graph and a graph of some logarithmic function, and then talk about that. So like we'll try to find out the properties of that graph also. First target is to draw a logarithmic function graph. Now logarithmic function graph, let's say if we talk about anything, any logarithmic function, then drawing its graph actually it requires your calculator, other things, because different thing log different values we do not remember, we do not know it. So the best technique always is to convert it to its exponential thing, then find some points, because exponential calculation is kind of easy for us. And as you know, exponential and logarithm, they are actually inverse of each other, so we can actually convert it from one to another. Now let's say we want to draw the graph of y equals to 3 to the power x graph. So y equals to 3 to the power x, this graph is drawing is like easy. We consider some value of x and we then plot it. So let's say x equals to 0 here, so 3 to the power 0 equals to 1. Say it is plus 1, then 3 to the power 1 equals to 3. Say this is minus 1, then it will be if it is 3 to the power minus 1, so it is 1 by 3. 1 by 3 means 0 0.33. 0 0.33. 1 by 3 means this. How this calculation came? See, this last one I will show. 3 to the power minus 1. 3 to the power minus 1 means 1 by 3. 1 by 3 means 3. Then we divide this one. We cannot divide, so decimal, put a 0. 3 divided by 3. 3 comes here, 1, bring another 0, write 3, 9, oh this is 9, then this is again 1, so again 0, again 9, this way it will continue. Okay, so this is just some graph. Anyway, now we are interested to draw this graph, and that graph will be, if we want to draw the graph, this is our coordinate axis. So say 1, 2, 3, 1, 2, 3, 4, like this, minus 1, minus 2, this is our x-axis, this is our y-axis, 1, 2, 3, 1, 2, 3, 4, minus 1, minus 2, this is minus, we do not need them right now. So let's try to plot it. So first of all, first point is, let me try to use some other colors if I have. I'm not sure, does it work? It works, but I'm not sure if whether or not you will see it. So for 0, x equal to 0, y is 1, this is the value. Then 1 equal to 3, for when x equal to 1, y equals to 3 is this point. Then when minus 1, it is 0 0.33, minus 1 is here, 0 0.33 is here. So this is our exponential graph. So this is the exponential graph of this function. So it will not touch this x-axis, it will not touch or cross. Okay. So this is the graph. So this is our exponential, but we are interested about the logarithm. Mainly we started the thing to find the logarithm, and you know what, the logarithm function is actually the inverse of the exponential function. So the same this one's logarithmic function will be just swap all the points, just switch it, like all the x value will become the y value, or the y value will come to the x value. So the value will look like, so the, you see this is 1, 3, 0 0.33, this will come to x now, so 0.33, and this side will come here now, so it will be 0, 1, minus 1. What we did here is we just switched all the value just to get their inverse. Okay, this box and this box is inverse of each other, and now we will try to draw the points. We'll try to draw the points, and the point will be, first of all, you see this is for 1, y equal to 0, that means this point, and this is x equals to 3, y equal to 1, that means this point, then x equal to 0.33, y equal to -1. That means here. So we get the graph like this. We get the graph like this. And similarly also it will not cross this line, because it is not crossing this line, because they are just a reflection of each other. And this will be the graph of one logarithmic function, which is y equals to log, it came from where, 3 to the power x, so it will be 3 base x. So this is the graph of log 3 base x. Okay, this is the graph of log 3 base x, and this one was the graph of y equal to 3 to the power x, y equal to 3 to the power x. And this is the logarithm error. So usually we do not show this part, we just directly draw it. Okay, but this comes from this data. First we write this data, then we convert it to this data. This is, it looks like it takes time, but usually if you don't do it, because you just do the calculation but don't plot it, reverse it, then plot it, you will get the logarithmic function graph. So it's not taking too much time. And as you know, if you draw a line to the middle, if you draw a line to the middle, the line will look like this. Line will look like this. This is y equal to x line. Okay, this is just in the middle, through the middle, 45 degree angle. If you think this is 0 degree, so 45 degree angle. This is y equal to x line, and always you will see the same this logarithmic function, and this is the actually compared one. Actually they will be the reflection of each other. Okay, this one, and then this is the reflection. If you think there is a mirror here, basically it is a reflection here. So this is how we can draw a logarithmic function graph. And now let's try to find out some behavior, some properties of this logarithmic function. Let's talk about this. What we understand from this logarithmic function. Remember, always exponential function and logarithmic function are inverse of each other. So, and they are one-to-one function basically. As they are one-to-one, so we can actually think about them like they are inverse. How do we know that they are one-to-one? Because if we draw our testing system, one-to-one means they will have one-to-one function. When we think about some one-to-one function, then we know that these functions will not have different, will have different y values for each x value. So that's the way, that's one way to think about that. And for all the one-to-one function, we have the inverse. So that's another clue for this one-to-one function. What will be its inverse? What they will represent? Anyway, let's try to find out some properties of it. For example, what will be the domain of this function? What will be the domain of this function? This logarithmic function. For this one, we are actually interested about the logarithmic part here. So the domain, you see, domain will be all this side, only all the value which is greater than 0. So the domain will be all the value where x is greater than 0. Okay, x is greater than 0, this side. And range is, you can see this side is going down forever, and this side is going down forever, going up forever also. So the range will be all the real number. All the real number will be the range. Okay, and as you can see, this is actually one-to-one function. One-to-one function, and then then you can see this is actually the inverse of y equals to inverse of, you can say inverse of, for this function we are doing inverse of y equal to 3 to the power x. This function, we are talking about this function. So if there is some other number, it will be some other number here. Okay, so there will be inverse of this function. Then what else you understand from here? So you see it has some x-intercept. X-intercept is at 1, 0. So intercept is 1, 0. Intercept is 1, 0, and there is no y-intercept. So no y-intercept. There is a asymptote here. This is the asymptote line. This is the asymptote line, and this is vertical asymptote, and vertical asymptote is y-axis. So another property is vertical asymptote y-axis or y-axis, whatever you call. So vertical asymptote is y-axis. Then what you understand? This is it increasing or decreasing? This is the increasing function. This is increasing graph. This is the increasing. If you go from left to right, then you will see all the values are going up. First it will touch it, then it will go this way. This is the increasing graph. And what else we understand from here? Another thing is this graph is smooth and continuous. Smooth and continuous. And continuous. This graph is smooth and continuous. You can see this graph is smooth and continuous. And we said this is one-to-one function, and hey, this is, suppose this is a one-to-one function. This is actually not a one-to-one function, because if you draw a line, it cuts our graph at 2 different points. But if you cut a horizontal line test, if you do some horizontal line, it will never cut our graph at 2 different points. Okay, so that's why this is a one-to-one function, and this is how we understand it. So anyway, is there any more thing that we can add here about this graph? Anything else? There is no oblique asymptote, we can say. So no horizontal asymptote, no oblique asymptote here, and I think this is good enough points from this graph that we understand from this graph. Is this fine? Yeah, I think these are good. Like by this way, actually, you can understand other graphs also. Basically, the simple idea is this: let's say if anybody tells you to draw some graph of y equal to log, let's say 4 base x. So like here 4 to the power x, then draw it. Say some other number comes here, let's say there is a negative number here, so give a negative number, then do the calculation. So the main format is y equals to a base x. Okay, this is the main format of logarithmic function, and we can actually interchange the numbers, and for the variable we can put many different numbers to get their output. And there are you do not have to, like, this is not necessary that you have to follow this process to draw the graph. But this is a bit handy to draw the graph without the calculator when you are not using the calculator. But there are some calculators where you have the base button and the variable button. So by that calculator, you can actually directly draw the graph, and you can directly get this chart, and you can find out the graph. So anyway, I hope it works. Thank you very much.